All right, so we were discussing this question of forces. So we just ended up with this part in which you have to find out the force F and you need to find out the tension, right? So both of them are done. The next part is actually related to the stress. So currently we have not studied stress. So just the remaining part for the time being, we are just going to skip. Or it come to question number 16. Mark question number 16 is a very important question, so let's discuss how to solve question 16. Question 16 says, state the principle of moments. So how do we define the principle of moment? Object is in equilibrium, right? Object is in a state of equilibrium if sum of clockwise moments about a point is equal to sum of anti-clockwise moments about same point. If you are going to write down these words, only then you will be awarded with complete 2 marks. So object will be in equilibrium if sum of clockwise moment about a point is equals to sum of anti-clockwise moment about the same point. So this definition is pretty very important. So now next question says, a statement says, in a bicycle shop, two wheels hang from a horizontal uniform rod AC. So there is a uniform rod A to C and it is shown in figure 3.1. This shows that rod has a weight of 19 Newton. So the rod which
Hmm.
is hanging downward is having a weight of 19 Newton and it is freely hinged to a wall at end A. The other end C of the rod is attached by a vertical elastic cord of the ceiling. The center of the gravity of the rod is at point B. The weight of each wheel is W, and the tension in the cord is 22 Newton. By taking moments about end A, show that the weight of each wheel is 14 Newton. So we have to find out the weight of each wheel. So how will this question be done? So we are going to take the help of what? We will be taking the help of principle of moments, right? So by taking moments about point and A. So this and A will be your pivot point. So if and A is your pivot point, first of all, we will notify how many forces are there. So there is one force, second force, third force, and fourth force. So these are the four forces we will be having. When four forces are here, one, two, three, four. Now we will be watching how many clockwise and anti-clockwise movements we are going to have. Due to this, there is an anti-clockwise movement, then there is a clockwise movement, there is a clockwise movement, and due to this, it's a clockwise movement. So let's explore how we can find out the weight in each case. So let's first find out the clockwise movement. So clockwise movement is this one, clockwise movement is this one, clockwise movement is this one. So when all of these are clockwise movements, so let's see what it is going to do. So first of all is the weight which is hanging downward. So this will be weight W multiply by this whole distance till pivot. What that distance will be equals to 1.85. Why it is 1.85? Because the distance from here till here will be 1.85 plus the distance, the next force is going to be 19. It is 19 multiplied by what is the distance from here till here? Though it's a uniform rod. So if it's a uniform rod, so weight will be hanging from the center. So whole of the length is how much? The whole of the length is appearing as almost 1.4 and 1.85 and 15. It is approximately equals to 2.6. So 2.6, the half of 2.6 will be appearing as 1.3, and plus another weight is W, and this weight W is at a distance of how much? 0.45. This all will be equals to what? Anti-clockwise moments. And what is the anti-clockwise moment? 22. 22, and the whole of distance is how much? The whole of the distance is 1.4, 1.85, and 1.85 plus 15 will be how much? It is 2.6. This whole distance will be equals to 2.6. Guys, are you understanding how we are going to apply the principle of moments in this case? So this is how it will be done. And at the end, after solving all of them, our weight will be appearing as 14 Newton. So by taking the moments about and A, the weight of each wheel will be equivalent to 14 Newton. Is this fine?
सर
Yes.
ये 19 की जो लेंथ आपने निकाली 1.3 है, किस तरह निकाली?
कौन सी 1.3? देखो 19 का अगर हम डिस्टेंस देखें, लेट मी चेंज द कलर। 19 का अगर हम डिस्टेंस देखें, ये 19 न्यूटन का टिल पॉइंट ए, पिवट तक लेते हैं ना डिस्टेंस, तो पॉइंट जहाँ पे
यस।
फोर्स लग रही होती है वहां से पिवट तक। तो ये 19, क्योंकि यूनिफॉर्म बीम है, ये यूनिफॉर्म रॉड लिखा हुआ है। इफ इट इज अ यूनिफॉर्म रॉड, तो इस पूरे की जो लेंथ है, पूरे की लेंथ हमारे पास कितनी है? 2.6 मीटर्स। तो वेट विल बी एक्टिंग एट हाफ। तो वेट कहाँ पर एक्ट
सेट है।
कर रहा होगा? 1.3 मीटर्स के ऊपर। तो दैट इज व्हाई आई
ओके
हैव
सर।
टेकन दिस वेट एज 1.3। इज दिस फाइन?
यस सर।
Okay, moving onwards to the next part. Its next part says determine the magnitude and direction of the force acting on the rod at end A. So, what is end A? This is the end A, and at end A, we will be inspecting that how does the force is exerted. So, let me say, okay, if I consider at this end A, the force is acting in this specific manner. Let's say मैं उस force को कह देता हूँ F. इसको upward ले consider करना, let me consider this force as upward, and I know this whole bar is in equilibrium. If this whole bar is in equilibrium, what I can say, sum of upward force is equals to sum of downward. Sum of upward forces will be equals to sum of downward forces, right? Sum of upward forces is equal to sum of downward, so upward is F plus of 22. F is upward, 22 is upward. This will be equals to weight is downward plus another weight is downward plus 19 Newton force is downward. So हम इसमें कौन सी इक्वेशन लगा रहे हैं? फर्स्ट कंडीशन ऑफ इक्विलिब्रियम लगा रहे हैं। Sum of upward forces equal to sum of downward forces. So we are aware about the weights. So what this force F will be equals to? Force F will be equals to weight is 14 plus 14 plus 19 minus of 22. So when we are going to solve this whole part, so we will be ending up with the value of magnitude of force as 25 Newton. So magnitude will be 25 Newton and direction will be vertically upward. This is how we will be solving this question. Is this fine?
Sir, why will we take it as upwards?
We haven't taken it as upward initially. We were not knowing about its direction. Either the force can be upward or it can be downward. If we would have chosen as downward now, so this force would have appeared negative. If it would have appeared negative, then we are going to say that it is not actually downward. It will be considered as upward, right? So luckily we have just started the question with the consideration कि let's say this force is upward. If this force would have been upward, then your answer will be positive. And yes, it appeared as positive, so it means कि ये actual में upward ही थी. But if We have taken it upward, but our answer is negative. This shows that we have taken that force direction initially in the wrong direction. Are you understanding? So eventually we
मतलब
ended up with
आंसर
the
पॉजिटिव
answer
आना
of
चाहिए.
force. We ended up with the answer of force as positive 25. So this indicates that the force is vertically upward. You understandable?
तो सर अगर आंसर पॉजिटिव ना हो तो गलत है.
आंसर पॉजिटिव ना हो तो इसका मतलब जो आपने इनिशियली डायरेक्शन एज्यूम की है वो आपने गलत की है, उसके ऑपोजिट डायरेक्शन है एक्चुअल में.
ओके.
जी गाइस, एवरीवन इज विद मी? ओके, दिस क्वेश्चन इज अगेन रिलेटेड टू हुक्स लॉ. सो इसके जो रिमेनिंग पार्ट्स हैं जब हम डिफॉर्मेशन का चैप्टर पढ़ लेंगे देन वी आर गोइंग टू अटेम्प्ट इट. तो अभी ये नेक्स्ट थ्री पार्ट्स आप फॉर द टाइम बीइंग यू मे स्किप. सो दिस इज द डेंसिटी पार्ट क्वेश्चन. अच्छा, क्वेश्चन 17 के ऊपर वाले पार्ट बेसिक हैं. ये डेंसिटी वाला भी आपसे हो जाएगा. हम इस पार्ट की तरफ थोड़ा देखते हैं कि हाउ इट वर्क्स, हाउ वी कैन फाइंड आउट द. कम टू क्वेश्चन नंबर 17 पीपल. ओके जी. So what is happening in this specific question? So let me just study it from the top. That there is a fishing rod AB which is made from the rod in B as in shown in figure 1.2. So this is figure 1.2 in which you are being shown with one of the dimensions. Uh, and A. This is and A, and an end A of the rod rests on the ground and string is attached to the other end B. So here the string is one of the string is being attached on the point B side. Okay. A support stick exerts a force perpendicular to the rod at point C. The weight of the rod acts at point D. The tension in the string is in the direction perpendicular to the rod. The rod is in equilibrium and it is inclined at an angle of 56 degree to the vertical. Next it says the force and the distances along the rod A, B, C, D are shown in figure 1.2. Question says show that the component of the weight that is perpendicular to the rod is 4.3 Newton. So we have to just find out the component of a weight which is acting perpendicular to it. So how will this be found? Yes, people, can you let me know how we are going to find out the component of a weight perpendicular to this? So where is the weight acting? The weight is acting this downward. So if the weight is acting downward, what is the perpendicular component known as? It will be a component which is acting in this direction, right? So this weight which is acting in this direction, और ये weight actually यूं downward act कर रहा है. So this part will be called as 5.2 sine of 56 degree. So what is the component of a weight which is perpendicular to the plane? It is 5.2 sine of 56 degree, and this whole value will be appearing as 4.3 Newton.
सर
जी.
इसमें किस तरह पता लगता है कि आपने वर्टिकल कंपोनेंट लेना है या हॉरिजॉन्टल.
बेटा यहाँ पे उसने लिखा हुआ है ना, you have to find the component of the weight which is perpendicular to the rod. So if this is a rod, this is a rod, तो उसके perpendicular component कौन सा होगा? ये वाला component perpendicular होगा. अगर weight आपका ये बन रहा है तो आपका perpendicular component इसके ये वाला पूरा बनेगा. Are you getting?
यस सर.
Okay. Next it says by taking moments about end A. Where is end A? This is your end A. End A is when it is said the moment about end A, a moment about this point. So that specific point will be considered as your pivot. So our point A will be considered as pivot in this specific case. So you need to find out the tension T. आपने tension T in the string जो है वो find out करनी है. So you have to find out the tension T in the string. जी, how will we be doing it? This is for pivot point A. ये point A आपका pivot है. तो यहाँ पे तो उसकी कोई force हम include नहीं करेंगे. फिर हमारे पास कौन कौन सी force रह गई? This is one of the force. This is one of the force. And this is one downward force. So let's first explore okay, which force is going to create the clockwise moment or anti-clockwise moment. So if we talk about this force, it is going to create an anti-clockwise moment. This force which is sticking upward, this will be creating a clockwise moment, and this tension which is downward, it will be creating an anti-clockwise moment. So what will be the relation with us? The relation of the forces with us will be somewhat like this. T multiplied by 2.4 plus of 4.3 multiplied by 1.2, this will be equals to 4.6 multiplied by 1.8. So we will be multiplying them. So this is created as a clockwise movement. Clockwise movement 4.3 into 1.2. This one is creating tension T and this whole distance is equivalent to 2.4. So here it is written as 2.4. And what is creating the clockwise movement? It is this force of 4.6 Newton to the right, and that is 1.8. So this is 4.6 into 1.8. So what will be the tension we are going to get? The tension in this specific case, it will be equivalent to 1.3 Newton. So this much tension will be equals to 1.3 Newton. Yes, is this fine to everyone? Okay, let's move up to the next question. Okay, this question is related to upthrust. Our next chapter is related to density and pressure upthrust. So we will be studying that chapter and will be solving question later on. So you may skip 18 for the time being. Okay, this is a short question. So let's solve this question as well. So question number 19. So let's see question number 19. Question 19 says there is one force of 45 Newton which is acting this way, and then there is a string which is at a tension T. There is one weight which is hanging as 9.6, and this is the point A. What is the question saying? The rigid plank is used to make a ramp between two different horizontal levels of ground, as shown in figure 4.1. Point A at one end of the plank rests on the lower level of the ground, and a force acts on and is perpendicular to the plank at point B. So there is one force which is acting perpendicular at point B. The plank is held in equilibrium. So this condition is very important, that it is in a state of equilibrium by a rope that connects point D on the plank to the ground. The plank has a weight that may be considered to act from its center of gravity. The rope is perpendicular to the plank and has the tension T. The plank is at an angle of 38 degree to the vertical. The forces and the distances ABCD are shown. Question says show that the component of the weight is perpendicular to the plank is 59. So it means that this is the weight which is hanging. So we need to find out which component. We need to find out this vertical component. So this vertical component, and this is called as its horizontal component, right? So we just know about this 38. So we want this specific part, the vertical component part. So if we are aware about this outer angle, so this part will be written as what? 96 sine of 38 degree. And what will be 96 sine of 38 degree equals to? This will be equivalent to 59 Newton. This will be equivalent to 59 Newton. Next it says, is everyone is with me? Just give me a minute. My pen has just got stuck. Okay. Next it says that you need to find out calculate the tension T. So this is the tension T which we have to find. Again, we will be solving it or doing the question in a similar manner. So what is a similar manner in which we can solve it out? It will be done the same way as we did in the previous question. So the moments due to tension T, we are going to take the moments about point A. So it says take the moment about point A. This point A is our pivot point. So what moments are going to be created? There will be this perpendicular component. It is going to create a anti-clockwise. Tension will be anti-clockwise and 45 Newton will be clockwise. So this is how we will be creating the moments. So what is the procedure of finding the moments for this? So we know this is going to create a clockwise moments. This tension T is going to create an anti-clockwise moment, and this force, perpendicular component of force, will be creating an anti-clockwise moment. So इसकी हमारी इक्वेशन क्या लिखी जाएगी? सबसे पहले क्लॉकवाइज लिख लेते हैं. क्लॉकवाइज मोमेंट के लिए हो जाएगा 45 multiply by what is the whole distance? This is 2.9. ठीक है, 45 into 2.9. This is clockwise, and what is anti-clockwise one? T into 1.8 plus of this vertical component found was 59, will be 59 multiplied by 1.5. So this is the equation we are going to use for part B. I'm just solving the part B above. So part B is having the value of t as equals to after solving this. So let me tell you what value we are going to get after solving the part 19. It will be equivalent to 23 newtons. So this is how question 19 is going to be solved. Our tension will be equivalent to 23 newtons. It is just a similar question the way we just solved the previous one. Okay, moving up to the next question. This question is pretty similar, so you can solve it out on your own. Um, this is just asking the condition of equilibrium. So here upthrust formula will be used, so we can skip for the time being. You may skip, do not solve 21. All right, moving onwards. Uh, for the time being, we can skip 22. You can solve it on your own. 23 is again having an upthrust part. So अभी हमने वो नहीं पढ़ा. This is also an upthrust related thing. Okay, this is the question 25. You can see. Let's discuss question number 25. Question 25 says state what is meant by center of gravity of the object. So question 25 is asking about the center of gravity of the object. So how to solve this question? What is meant by the center of gravity of the object? तो मैं इसको explain नहीं करूंगा, बस मैं आपको discuss कर लेता हूँ थोड़ा सा. Center of gravity क्या होता है? It is a point where the whole weight of the objects appears to act. ये एक ऐसा point है जिसमें जहां पर एक किसी भी body का weight appear करेगा. Weight is going to act. That is called as center of gravity. Okay, let's see the main part of this whole question. The main part of this question is saying that a uniform beam AB is attached to a frictionless hinge to a vertical wall at end A. The beam is held so that it is horizontal by the metal wire CD, as shown in figure 3.1. The beam is of length 0.96 and weight is 23 Newton. A block of weight W rests on the beam at a distance of zero point 0.2 meter from the end B. The wire is attached to the beam at point D, which is a distance of zero point 0.4 meter from end B, and the wire exerts a force on the beam of 45 Newton at an angle of 37 degree to the horizontal. Question says, what is the vertical component of the force exerted by the wire on the beam? So what we are going to find out here, we will be finding out the vertical component of the force. So what is the vertical component of the force? We will find vertical component से मतलब क्या है कि we will be finding out this component of the force. So we know if 45 is acting and it is acting at an angle 37, so this will be equals to 45 sine of 37 degree. So 45 sine of 37 degree will be equivalent to what? It is going to give you an answer of 27 Newton. So the vertical component will be equivalent to 27 Newton. Next question says by taking moments about point A. So where is point A? This is my point A. ये हमारा pivot point होगा. So how many forces are acting? One is weight. It is going to create clockwise moment. One is this vertical force. It is going to create anti-clockwise moment. And one is 23, which is going to create clockwise moment. So let's see how will this work. This is for clockwise movement. It will be for clockwise movement. It will be W multiplied by what is the whole distance? It will be 0.76 plus there is a 23 Newton part. So 23 is the weight which is creating a clockwise movement. So 23 will be multiplied by 0.48 because whole of the length is 0.96. So 0.96 divided by 2. And next we will be having anti-clockwise one. This is the vertical force and it is acting at 27 multiplied by the distance till point A is 0.56. It is 0.56. This is the distance for this force, right? So we will be solving this whole relation and our weight will be equals to what value? This whole weight will be appearing after solving this as 5.4 Newton. So this weight will be equals to 5.4 Newton. Actually, this is a question which is related to principle of moments. Is this fine? Okay, next question says the hinge exerts a force on the beam at end A. Okay, so the hinge exerts a force on the beam at end A. So there will be one force which is exerted by the beam at exerted by the sorry. Let me read. Take the question. The hinge exerts a force on the beam at and A. Calculate the horizontal component of this force. So what will be the horizontal component of the force? So it is similar as 45 cos of 37. So that component of the force will be equals to what? 45 cos of 37 degree. So 45 cos of 37 will be equivalent to what? It is equivalent to 36 Newton. So the horizontal component of the force will be 36 Newton. Next it says the block is now placed closer to point D on the beam. State whether this change will increase, decrease or have no effect on the tension. So see, now block D is moving closer. So when block D will be moving closer, when the block D is moving forward, so will it be creating more tension or the tension releases, decreases or what? So as this block was to the right, so there was heavy tension, more stretch was there in the string. So when it will be moving towards left, so the tension in the string will decrease. So here you are going to state that it decreases. It decreases, right? So this stress is for the time being, we have not studied it. So it will be studied in the coming couple of chapter after couple of chapters. So we will be discussing it later. So more or less, now all the remaining questions are pretty simple. So I do believe that they are practicable and you can like give an attempt to solve them out. So we are just going to stop here and the rest of the questions जो मिलते जुलते हैं forces से related, movement से related, you can attempt them on your own, right? अब सिर्फ दो चार क्वेश्चन रह गए हैं, बाकी तुमने कर लिए, लाइक ये वाला है, माइट भी ये भी हम क्लास में कल एक तो डिस्कस कर लें. और this is it from today's class. अच्छा, coming class will be within a day or so. In that class we will be discussing about momentum questions, right? We are going to discuss the momentum questions from the similar topical booklet. Is this fine, guys? So thank you very much for your patience and